This is an orientation and background for Natural Disasters Lab 11 about tsunami and storm surge hazard assessment. The materials that are needed for this exercise are a worksheet to fill out and hand in, and also a link to the story map, which contains the information and instructions for the exercise. First, we'll take a look at the story map that is behind this whole exercise. The first slide is a map of historic tsunami events that have occurred actually to the United States. And there are several locations in the United States where tsunami have occurred. Alaska and Hawaii, having a great deal of exposure to the open Pacific Ocean, have been subject to several tsunami over time, including the ones that are pictured here. There's also been tsunami that have affected Virgin Islands and Puerto Rico, and tsunami have also affected the west coast of the United States significantly, including some historic events in the northwest United States that we have just enough historic information about to realize that they did occur, and they were enormous, serious events. There are subduction zones in this area in the Pacific, off the northwest of the United States. There's subduction zones and such all along the Aleutian Islands in this area, and volcanoes as well, and Hawaii being right in the middle of the ocean. Any tsunami crossing the ocean from any part of the Ring of Fire is likely to affect Hawaii. So the United States does have tsunami events. Unfortunately, nothing incredibly destructive in recent history. The text box on this slide does give a summary of how tsunami occur and why they're dangerous, and some background information to support what we've learned in lecture. And there is USGS does have a tsunami hazards program, and they have a home page at this location. Storm surge is something we also studied in class, usually generally associated with a hurricane or a powerful low pressure system driven storm. And just a random picture of a storm surge event compounded by wave action along a shoreline, and a brief description of what storm surge actually is to supplement what we learned in class. For this exercise, for this week, we're going to use the same map, the same area, the same data set that we used for a previous lab. On this map is shown, and this is just a snapshot of the map. On this map is shown 6 sites, made up sites, with the number that identifies them is to the upper right, so that's number 2, number 3, 4, 5, and 6. And some made up soils, which I've made up a map of, which you can use to determine the soil type and then the soil stability. So we have each of these locations and the soils that are found there. The ones I'm claiming are found there, and that'll be what looks just like the live exercise, but this is just a snapshot to get you started. The worksheet is again similar, and you'll be placing each of the 6 site designations in one of these boxes, depending on whether it's 10 feet or less above the normal water level. 10 feet is a possibility that there could be a storm surge. Were there to be an intense extratropical cyclone on Lake Ontario, it could generate a storm surge, and we'll just use 10 feet as an example, possible water rise to assess these sites. It's possible there could be a tsunami from Lake Ontario into Irondequoit Bay. Most likely, if it were the astronomically small chance caused by an astronomical object, if you get the pun, there could be an impact event which could generate a tsunami on Lake Ontario. The odds are smaller than just about anything else we've ever considered. But if there were a tsunami, we could assess whether one of the sites could be inundated by a 70-foot water rise, and everything above 70 feet above the water, anything more than 70 feet above the water level would be never flooded. And in the same way that we looked at the landsliding stability, the soil susceptibility and the soil stability for landsliding, we can use the same data set to judge whether the soil is stable, moderate, or unstable. Because even an area that is not submerged by some event, such as storm surge or tsunami, even an event that's not actually submerged, that event could be enough to saturate the soil and to cause it to erode and potentially landslide. So the tsunami or storm surge could have two effects. One is to submerge an area, another is to cause some sort of erosion, undercutting, and landsliding. So let's look at the light, and just to remind, jumping over to the end here, once we identify the soil series, or the soil map unit symbol, we can see that we have erodibility. This soil is very erodible. That soil is very stable, and then these two, and probably that one in the middle. So you can make that judgment. Here's the live map for the exercise. If we were to assess a certain point, we can see clearly that point number 4 is in the blue, which is a BE soil, which allows us to go back over to here and see that that is a unstable soil. So on the worksheet, if I can find that, on the worksheet, the site 4 would be an unstable soil in one of these locations, or one of these boxes. And looking closer at the map, if we zoom in, as it did before, we find that the soil type disappears and the topo map becomes clear. As I said in the exercise, every one of these is a 10-foot. These are 10-foot contour intervals. So here's the water level. Every time we cross a contour interval, moving uphill toward a site, that's 10 more feet. So if this is normal water level, that's 10, 20, 30, 40, 50, 60, 70, 80, 90. It looks like 100 feet above. So site 4, no matter even if there were a 70-foot water rise for whatever reason, maybe a tsunami, site 4 would not be submerged. So that means, going back to the worksheet, although site 4 is unstable, it's never flooded. So this box right here would be filled in with site 4. And once you fill in the whole grid with all 6 items, then you can go ahead and rank the items. Clearly, a site that is on a stable soil and is never flooded, no matter even a 70-foot or rise, so any location that ends up in this box is going to be very safe, and a location that's flooded even by a 10-foot water rise and has unstable soils is going to be very unsafe. So this is the safest, and this is the worst, and all of these others you will have to make some sort of a judgment call or a ranking. So again, it says you'll need tiebreakers, some thought and interpretation, but I do think that the rankings do come out once you fill in the box and make the rankings. And that's the extent of this exercise. It'll be due, I think, yes, it'll be due as soon as you return from Thanksgiving break. This one will be due.